Hello, my little mathematicians. Today we are going to review Unit 1, Mods 1 through 3. The first thing we're going to start with is reviewing the different types of numbers, okay? So we divide them up into different categories. The first one is whole numbers, so that's like 0, 1, 2, 3, 4, 5, 6, 7, etc. Integers include all of the whole numbers plus their opposites. So 0, 1, 2, 3, 4, 5. The other side of that would be -1, -2, -3, -4, -5, etc., going in that way. Rational numbers include all of those plus the numbers in between. So that includes positive and negative fractions and decimals, as well as, of course, integers and whole numbers. So let's start with 105. Is 105 a whole number? Yes, it is. If it's a whole number, that means it's also integer and rational, because remember, these include that as well. It's just more things added onto it. So 0, yes, it is a whole number, which means it's also integer and rational. -10 is not whole, because whole numbers are only 0 and positives. Integers are the whole numbers and their opposites. So yes, since it's a whole number, it's not a fraction or a decimal, it is an integer and therefore also rational. -5.2 is not a whole number. It's also not an integer, because remember, integers can't include fractions or decimals. So it's only rational. Now this one's tricky because I just said, remember, integers can't include fractions or decimals. And you're like, oh, it's a fraction, so it's only rational like the previous one. However, can this reduce? Yes, it can. 10 over 5 reduces to 2. So in reality, this isn't a fraction, it's really just 2. So 2 is a whole number and an integer and rational. 3/4 can't reduce anymore, so it's not a whole number, it's not an integer, it's only rational. So there's your little review for the different types of numbers that make up our number system. The next thing is to convert each fraction to a decimal. There's two ways that I could do this. The first way is I can make the denominator become a base of either 10 or 100, which in this case I can. So 5 times what is 10? 2. So do the same thing on top. 2 times 2 is 4. Now that you have a base of 10, you can easily convert that to a decimal. I know that 4/10 is 0.4 because 4 is in the tens place. That's it. That's all the work you'd have to show. But of course, the way that always works is if you take the top number and divide it by the bottom, you can convert a fraction to a decimal. Remember, top dog always goes inside the house or in and out, okay, like the restaurant, in and out, inside the house, outside the house. So 2 goes inside, 5 goes outside. 5 can't go into 2, goes in 0 times. So what I do is I add a decimal and a 0. Now I have 5 into 20, which it can go in 4 times. And I still get 0.4, whether I did it this way or this way. The only thing is, like, yeah, this way is easier sometimes, but this way doesn't always work. If your denominator can't become 10 or 100, then you always need to rely on long division. Take the top divided by the bottom. Just like this one. I can't multiply 8 by anything to get 10 or 100. So I'm going to have to do long division. 5 inside the house, 8 outside the house. Remember, in and out. 8 can't go into 5, so I add a decimal and a 0. 8 goes into 50 6 times. 6 times 8 is 48. When you subtract that, you get 2. Always double check when you're doing division that this is smaller than what you're dividing by. If not, erase this and erase this. You didn't pick a big enough number up here. But luckily, 2 is less than 8, so I can keep going. Bring your next number down. 8 goes into 20 2 times. 8 times 2 is 16. When you subtract that, you get 4. Again, this is less than what I'm dividing by, so I'm good to bring my next number down. 8 goes into 40 5 times. When I subtract that, I get 0. Whew, finally, I'm done. And I wrote a 8 because I'm tired. Okay, 0.625 is my answer right here, 0.625. That was a review of converting fractions to decimals. Now let's convert decimals to fractions. These are a little bit easier. Okay, the number after the decimal goes on top. And then what place is this in? It's in the tens place, so it goes over 10. If it can reduce, we'd reduce it. And then this one, 24 goes on top. And the 4 is in the hundredths place, right? Tenths, hundredths, thousandths. There's no such thing as a oneth place. So this starts in the tenths place. So tenths, hundredths, I'm going to put it over 100. Or the nifty trick that I like to remember, if that's confusing for you, is there's one number after the decimal, so 1 0. There's two numbers after the decimal, so 2 zeros. Once you have your fraction, double check if you can reduce. I can. I'm going to divide by 2. So 24 divided by 2 is 12. 100 divided by 2 is 50. Oh, I can reduce again. So divide by 2. 12 divided by 2 is 6. 50 divided by 2 is 25. Double check. Nothing can go into both those numbers, so I'm done. Those of you that divided by 4, 24 divided by 4 is 6. 100 divided by 4 is 25. Yes, you could have done that. You would have gotten there faster. The bigger number you choose to reduce by, the faster you get to your answer. I'm going to throw one bonus one in here. What if I had 5.3? Okay. Well, that whole number stays in front. The number after the decimal, it's kind of like what we were doing before. That number after the decimal goes on top. It's in the tenths place, so it's 3/10. And then if I could reduce that fraction, I'd reduce that fraction. Since I can't, I'm done. But just remember, if there was a whole number out in front, you just put the whole number out in front. It's only the numbers after the decimal that make up part of a fraction. All right, let's move on and try to compare numbers. These are inequality signs. This is a less than sign because it kind of looks like an L, right? And then that's a greater than sign, and that's an equal sign. You always want the great big open end to face towards the bigger number. So what's bigger, 10 or 2? 10 is. So I'm going to have the great big open end facing the 10. And when you read it, it says 10 is greater than 2. For the next one, obviously a positive is bigger than any negative. So again, 10 is greater than negative 2. This one is a little bit trickier when there are two negatives. You could draw yourself a little number line, 0, -1, -2, -3. I don't even need to go all the way out to -5. But as you see, as the numbers get bigger on the negative end, they're actually smaller because the bigger the numbers are going to the right. This is where numbers are closer to becoming positives. So actually, the smaller the negative, the bigger it is because it's closer to being positive. Or what I quickly think to myself is I think of negatives as owing money. Would I rather owe $2 or would I rather owe $5? Oh, I'd rather owe $2, huh? So -2 is greater than -5. All right. For the next one, what's bigger, 5 or 6 3/4? Just look at the whole number parts. What's bigger, 5 or 6? 6 is, right? For the next one, I can reduce this. So let's try and figure out what this is. 10 divided by 2 is 10. So 10 is equal to 10. So I put an equal sign there. Because 20 over 2 is the same thing as 10. So those numbers are equivalent or equal. I could either change them both to fractions or both to decimals. This would become 8/10, and then I'd have to eventually do this one. So I like to change them both to decimals. So I'm going to take the 5 and divide it into 3. Remember, top dog goes inside the house, or inside the house, outside the house. 5 can't go into 3, so I add a decimal and a 0. 5 goes into 30 6 times. When I subtract that, I get 0, so I'm done. 3/5 is the same as 0.6. So what's bigger, 0.8 or 0.6? 0.8 is. Okay, so that kind of brings us to when you're given a decimal or fraction, before you can compare them, you have to make them both be in the same type of format. Put them in either both decimals or both fractions. And I prefer to put them all as fractions. So I'm going to use this piece of paper over here because we didn't really get enough space for this one. Okay, I want to write these numbers from least to greatest. I always underline least once and greatest twice, just as kind of like a visual for me of small to big when I'm done and I want to write out the list. Okay, so I have 0.25, 0.245, and this 2/5 I need to convert to a decimal so I can compare them. So 5 goes into 2 how many times? Well, 5 can't go into 2, so I add a decimal and a 0. 5 goes into 20 4 times. When I subtract that, I get 0. So 2/5 is the same thing as 0.4. Now, when you're going to compare decimals, what's really important is that they all have the same amount of numbers after the decimal, meaning this one has 2 numbers after the decimal, this has 3, and this has 1. This has 3, so I want them all to have 3 so I can more easily compare them. So add a 0 here and add 2 0 placement holders there. Now I can actually compare them. So I'm going to list them, double check. It wants least to greatest, so small to big. So the smallest one of this list is what? It's the 245. The next one is the 250. And then the last one is the 400. And just double check. Yes, yes, yes. Okay, it's in the correct order. After you have it in the correct order, you always want to rewrite it how it was initially given to you. So the 0.245, that's how it started. The 0.250 was initially given to you as 0.25. And the 0.400 was actually initially, wasn't it given to you as 2/5? So that's the correct order of how the things were initially given to you. And the reason for that is because what if 2/5 was really like 0.8 or something, and I converted it wrong? Like, I need to know that at least you have them in the right order here, because you kind of be hurting yourself if you put 0.4 and in reality it was like 0.8 or something. So please always make sure your first step is put them all in the same format. Then make sure they all have the same amount of numbers after the decimal. Once you have that, you can actually put them in the correct order and then rewrite them in that order, but how it was initially presented. 0.245 started that way. The 0.250 started as just 0.25, and the 0.4 was initially given to you as 2/5. Okay, so I'm going to go ahead and write that on my paper right here. 0.245, 0.25, and 2/5. For my next one, this time it wants it from greatest to least, so big to small. My first step is still the same. Let's go ahead and write them all down. I have 0.26 and 1/5 and 1/4. Okay, so 0.26 I can keep like that, but 1/5 I'm going to have to change to a decimal. 5 goes into 1 0 times, so add a decimal and a 0. 5 goes into 10 twice. When I subtract that, I get 0, so my final answer is 1/5 is equivalent to 0.2. I also need to change 1/4 to a decimal. So 4 goes into 1. Remember, top dog goes inside the house. 4 can't go into 1, so add a decimal and a 0. 4 goes into 10 2 times. 4 times 2 is 8. When I subtract that, I get 2. Bring down your 0. 4 goes into 20 5 times. Subtract it, you get 0. Finally, you're done, 0.25. Now remember, we always want to make sure that they have the same amount of numbers after the decimal. So let's add a 0 placement holder there. Now they all have 2 numbers after the decimal. And double check your directions, big to small this time. So the biggest one I see is 0.26. Then it's 0.25. Then 0.20. Do one last double check. Big to small. Big to small. Yep, okay. And then you just rewrite it how it was initially given. 0.26 started that way. 0.25 started as 1/4. and 0.20 started as 1/5. So that is now written from greatest to least. Finally, an easy one. Write the opposite of the integer. Well, the opposite of a negative 22 is a positive 22. And then again, write the opposite of the integer. Well, the opposite of a positive 16 is a negative 16. That's it for the front side. Only one more side to go. Let's go ahead and flip it over. Okay, and we're going to review absolute value. Remember that for the majority, whenever you see absolute value means the distance a number is from 0, right? And if you're talking about distance is always positive. So let's say I had 2 and negative 2. 2 is 2 away from 0. Negative 2 is also 2 away from 0. So the absolute value of negative 2 is 2. And the absolute value of 2 is still 2. So it's different than opposites. Absolute value is the distance it is from 0. It'll only get a little bit tricky is if it asks you to take the opposite of it, which will be indicated by a negative sign out in front of it. So if you see a negative out in front of absolute value signs, that's when it gets a little bit weird. All right, let's start with the first one. The absolute value of 8 is just 8. The absolute value of negative 8, how far is negative 8 from 0? It's 8 away, kind of just like that example we talked about. Now this one, work your way inside out because just focus on the absolute value part first. The absolute value of 8 is 8. And then that negative's out in front of those signs, so it's saying what's the opposite of positive 8? A negative 8. Okay, this one, ignore that for now. What's the absolute value of negative 8? It's 8. And what's the opposite of that positive 8? A negative 8. Okay, it's all inside the absolute value sign. So the opposite of negative 8 is a positive 8. I simplified it down in there. Now, what's the absolute value of 8? The absolute value of 8 is positive 8. Okay, I'm going to ignore this one out in front again. But inside these absolute value signs, the opposite of negative 8 is positive 8. Right? And then that was out in front. Okay, the absolute value of 8 is 8. And then that negative out in front is saying, what's the opposite of 8? A negative 8. So that's kind of how you think about it and why it happens that way. But let me just show you something. I said, think of absolute value as being positive, right? Because absolute value is a positive distance. If you see a negative in front of absolute value signs, that's not in front of the absolute value signs, that's still within them. No, right here and right here. Notice that when there was a negative in front of the absolute value signs, that's the only time that your answer resulted in a negative. Because whenever you take the absolute value of something, it's positive, right? And then that negative out in front was saying, what's the opposite of that positive? Oh, a negative. Okay, so if there's no negative out in front of your absolute value signs, it doesn't matter what's in there. It's a positive. The only time you get a negative answer with absolute value is if there's a negative out in front of those absolute value signs. All right, feel free to kind of rewind that part of the video several times so that sinks in. And let's move on. The next part says, please compare these numbers using, again, the inequality signs of less than, greater than, or equal to. So when you do this, first of all, I have to take the absolute value of the ones that require me to. So the absolute value of negative 9 is 9, and that still stays 7. Okay, what's bigger, 9 or 7? 9 is. What's the absolute value of 8? What's the absolute value of negative 10? What's bigger, 8 or 10? 10 is. So the great big open end is facing the 10, and the great big open end was facing the 9. What's the absolute value of negative 3? A 3. What's the absolute value of negative 5? A 5. What's bigger, 3 or 5? 5 is. So 3 is less than 5. 8 is less than 10. 9 is greater than 7. That's how you read the signs. You always read them like going left to right. But also to kind of double check yourself is the great big open end should be facing the bigger number. All right, let's move on to our next section. It says, please find the GCF of these set of numbers. Our favorite method to use is the ladder method. So let's go ahead and do that. So what numbers do you see that can go into both 30 and 50? You could pick 2 or you could pick 5. I'm going to do 10 because they both end in 0. And remember, the bigger number you choose out here, the smaller your ladder is. 10 goes into 30 3 times. 10 goes into 50 5 times. Always double check before you move on. 10 times 3 is 30. 10 times 5 is 50. Yep. So this number times this should always equal the number up above it. Once you check that, go ahead and see, can I add another step to my ladder? No, because nothing can go into both 3 and 5. So I'm done with my ladder and I circle the number out in front, and that's my GCF. It's 10. If there was more than one number, you would multiply those along the side. Okay, let's try this one. I'm going to start with 2. 2 goes into 24 12 times. 2 goes into 30 15 times. Let's just double check. 2 times 12 is 24. 2 times 15 is 30. Yep. Okay, now can I find anything else that goes into both 12 and 15? Let's add another step to our ladder because 3 can go into both of those. 3 times what is 12? 4. 3 times what is 15? 5. Double check. 3 times 4 is 12. Yep. 3 times 5 is 15. Yep. Okay, do I see anything that can go into both of these? No. So I circle the numbers along the outside, and GCF is 2 times 3. 2 times 3 is 6. So for that one, my GCF was 6. Now your ladder could look a little bit different if you chose different numbers. Some of you could have started with 3, and some of you could have started with 6. Regardless, you end with 4 and 5 at the bottom, and you got a GCF of 6. Let's move on to the next one. 65 and 80. Well, they both end in 5 or 0, so I know that 5 can go in. And 5 times what is 65? Well, 5 times 12 is 60, so 5 times 13 is 65. For 5 into 80, I might have to do some long division here. 5 goes into 8 once. Subtract that. 3 is less than 5, so I'm good to keep going. 5 goes into 30 6 times. Finally, I'm done. 5 times 16 is 80. And yeah, 5 times 13 is 65. Or if you want to double check yourself, multiply it out. Yep, it's right. Okay, can anything go into both 13 and 16? No. So I'm going to circle the 5 out in front, and that's my GCF. Okay, these next set of directions. Use the distributive property to express a sum of 2 whole numbers times their GCF. Or it might say rewrite this as a product of the GCF and a sum. They're both saying the same thing. Okay, so first off, use the word GCF. So I need to find the GCF. So let's do my little ladder. And for those of you that the ladder method is new to you, you're going to see why I like it so much, because especially for these types of problems, so helpful. Okay, 5 can go into 50 and 65, and 5 times 10 is 50, and 5 times 13 is 65. Nothing can go into both 10 and 13, so I'm done. What I do is the GCF is that number out in front, right? So I'm going to write the GCF, and it's that times a sum. The sum is these 2 numbers down here. So 10 plus 13, and we put those in parentheses. And how you double check yourself, if you distribute that 5 out, you should get what you started with. 5 times 10 is 50, plus 5 times 13 is 65. Yep, I know I'm right. So again, if you distribute it out and you get what you started with, and if the numbers inside the parentheses don't have a GCF in common, you know you're right. Because if for some reason, if this was like 10 and 12, 10 and 12 have something in common, so your your ladder wouldn't have been complete. You need to try again. All right, let's try this one. What can go into both of these? They're both even, so let's do 2. 2 goes into 16 8 times. 2 goes into 24 12 times. What can go into both of those? 4 can. Okay, some of you guys might have picked 2. That's okay. I picked 4. Regardless, even like you can pause the video and you can work it out with your 2 and we should still get the same answer. Okay, 4 times what is 8? 2. 4 times what is 12? 3. I can't keep going, so I'm done. Here's my GCF along the outside. 2 times 4, which is 8, times 2 plus 3. And always double check. 8 times 2 is 16. Plus 8 times 3 is 24. And 2 and 3 have nothing in common, so I know I'm right. Okay, final one of these. What can go into both 12 and 30? 2 can, 3 can, but I see that 6 can as well. 6 goes into 12 twice. 6 goes into 30 5 times. Okay, double check. 6 times 2 is 12. 6 times 5 is 30. Nothing can go into 2 and 5, so I'm done. I'm going to put my GCF out in front, and then these make up my sum. 2 plus 5. Double check. Nothing can go into 2 and 5, and when I distribute it out, 6 times 2 is 12. 6 times 5 is 30, what I started with. So I know that that is indeed the correct answer. Okay, and if that wasn't enough reason of why the ladder method is so cool, even when I want to find the LCM, I can do the ladder method again. What can go into both 6 and 12? 6 can. 6 times what is 6? 1. 6 times what is 12? 2. 6 times 1 is 6. 6 times 2 is 12. Can anything go into 1 and 2? No. Here's where they differ. If I'm asked to find the GCF, I just circle the 6. But if I want to find the LCM, look at this little thing I draw right here. What does that look like to you? It looks like an L, doesn't it? So all the numbers within that L along the outside are going to get multiplied together when I'm dealing with the LCM. Okay, because that L doesn't stand for love like it should. It stands for LCM. 6 times 1 is 6. 6 times 2 is 12. Okay, and that makes sense because for these ones up here, GCF is the greatest common factor. Factor is a number that can divide into each of these. So what's the biggest number that can divide into both 30 and 50? It's 10. A multiple is what's the biggest number that they both can multiply to become? Well, 6 times 2 is 12 and 12 times 1 is 12. Both numbers can multiply to become 12. And that's how LCM and GCF are different. Okay, but again, I can still use the same method to find them. I start with my ladder. 3 goes into both 6 and 15. 3 goes into 6 twice. 3 goes into 15 5 times. 3 times 2 is 6. 3 times 5 is 15. Yep. Can 2 and 5 have anything in common? Nope. And then again, the only thing that's different about GCF and LCM is I'm going to do the L along the outside for LCM. And 3 times 2 times 5. 3 times 2 is 6. 6 times 5 is 30. Double check. 6 can become 30. 6 times 5. 15 can become 30. Yep, 15 times 2. Okay, and our final one of these. What can go into both 24 and 30? 6 can. 6 goes into 24 how many times? 4 times. 6 goes into 30 how many times? 5 times. Double check. 6 times 4 is 24. 6 times 5 is 30. And the reason I'm making you double check this is sometimes you rush a little and your head does funny things, and then you get your quiz back and you're really frustrated because you're like, oh, I knew that. If you take the 2 seconds to just double check, 6 times 4 is this number. Yep. 6 times 5 is that number. Yep. If you had made an error, you usually catch it there and you can erase it and do it again, and you'll save yourself a lot of tears from when you get your quiz score back. Okay, moving on. 4 and 5 have nothing in common, so I keep going to find my LCM, multiply the numbers along the outside, and you have 6 times 4 times 5. Well, 6 times 4 is 24. 24 times 5 I could figure out if I did this, but you know what's nice about just when you're multiplying the commutative property, you can multiply in different orders because 2 times 3 is 6. If you switch them, 3 times 2 is still 6. So I can start at the end, and sometimes that might make the numbers easier because 6 times 4 is 24. 24 times 5, I don't know that. But 5 times 4 is 20. 20 times 6 is 120. Okay, and if it's not easier the other way, fine. You could work it out this way and you would still get 120. Now, when do we see GCF and LCM in real life? Okay, one of these problems is a GCF and one of these is an LCM. Let's see. It says a soccer team has 8 girls and 10 boys. The coach wants to divide them into groups with the same number of boys and girls. What is the greatest number of groups the coach can make? In case you haven't figured it out yet, this is a GCF problem, okay? Because I want to know the greatest amount that I can make. So 8 and 10. Okay, I'm going to go ahead and pull out, they have a 2 in common. 2 times what is 8? 4. And 2 times what is 10? 5. I can't keep going. So my answer is the biggest amount of groups I can have is 2. That's my GCF. Now, what's really nice about this is you're like, why did I do this sum thing? Like, what does that even mean? What this means is you have 2 groups, and in each group you have 4 girls and 5 boys, because that's what this was standing for, right? So 2 groups with 4 girls and 5 boys. So you have 1, 2, 3, 4 girls and 1, 2, 3, 4, 5 boys. And you have not 1, but 2 of those groups. So duplicate that. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 5, 10. There's your total amount of boys you started with. 4, 8. There's the total amount of girls that you started with. So 2 groups that are both exactly the same. And that's what GCF is representing in real life. Okay. The next one says, beginning at 8:30 a.m., tours of the National Capitol and the White House begin at a tour agency. Tours for the National Capitol leave every 15 minutes. Tours for the White House leave every 20 minutes. How often do the tours leave at the same time? So for this one, every 15 minutes, so you go like, okay, 15 minutes, and then after another 15, you get 30, and after another 15, you get 45 minutes. Those sound like multiples to me, right? And then after every 20 minutes, okay, so 20 minutes have passed, another 20 minutes have passed, I get to 40 minutes, another 20 minutes have passed, I get to 60 minutes. Again, that's talking about multiples. And you want to know, when will they leave at the same time? So when will finally both times end up being the same time? So when are they going to have a common multiple? This is the least common multiple. Okay, so I'm going to do the least common multiple of 15 and 20. What can go into both 15 and 20? 5 can. 5 times what is 15? 3. 5 times what is 20? 4. Nothing can go into both 3 and 4, so I'm going to multiply all the numbers along the outside to find my LCM. 5 times 3 is 15. 15 times 4 is 60. So what that means in real life is that every 60 minutes, both groups will leave at the same time. Okay, so every 60 minutes, both groups will leave at the same time. Congratulations at mastering all of Unit 1. I am so proud of you.